Okay, so today we've got Adam as our speaker. I'm going to pin his video, and he's going to talk about a whole bunch of tech stuff that he's experienced in his career. So I'm going to let Adam, you take it away. And please, everybody who's on the call, please 100% jump in and ask questions. If there's anything you want to ask Adam about, please feel free, because he's happy to answer anything you might be wondering. So Adam, it's all you.
Thanks so much. Really glad to be here. Thanks so much, David and Brianna. Yeah, so hey everybody, my name is Adam Baumgartner. I'm an embedded systems engineer with XStream Trucking. What I want to talk to you about today is I'd like to talk to you about kind of what I've observed in kind of how technology in 2020 is changing incredibly fast. And nobody really seems to be able to keep up with it. And what are the types of things that are happening, and kind of what observations exist, and how can we work to do the best we can to kind of continue to stay relevant? It's definitely a huge challenge that a lot of people are working on. So what I want to do is I want to first talk about my background. We'll talk a little about like how I kind of perceive like the engineering space. I've been really lucky to work in like a bunch of different parts of engineering. And then we're going to kind of go through the different sectors. And then finally, I'll kind of give you my thesis, my opinion for where I see things going. And from there, a great example that I see that's kind of like a case study for this type of rapid change and how it is really changing the landscape. So, oops, can't do that, gotta do this. So yeah, so a little bit about my background. So I'm a mechanical engineer from Johns Hopkins University in Baltimore, Maryland. I was there from 2017 to 2010. And as I mentioned, I was a mechanical engineer. And so I worked on an off-road vehicle team. I was very focused in like CAD design, and very excited about those types of activities. Then I went to work at Honda R&D in Columbus, Ohio. This is the same Honda that makes cars, trucks, and minivans. And I was a design engineer, and I worked on the crash structure, a very mechanical product in the cars, making them safer. So when you impact something, we have the parts crushed slowly, and you don't just come to a complete stop quickly. When I was at Honda, though, I was starting to see there was this connection between automation and making software differences, because simultaneously at Honda, I transferred to the test group where I was a test driver after doing a little bit of stint as designing the crash structure. I then worked on the design of doing the testing for acceleration performance. And we were doing a lot of post-processing, and so I automated that. And I was realizing there's a lot of really cool opportunities in terms of automating things. So I pivoted my career to work more in software. I did more and more software at Honda R&D, and I was really lucky to get a chance to join an early stage startup, XStream Trucking, out in the Bay Area basically in the fall of 2016. And what I did is I joined, and I'm the main contact for developing the control unit. XStream Trucking sells a device that opens and closes the trucks, the gap between the cab and the trailer on semi-trucks. So it improves the fuel economy. What's really exciting is that I got to make a device that connects to the truck's CAN network, figures out information to know when to open and close these wings. Also, it was connected to the internet that enabled us to feed forward information to clients that we were selling our device to share with them how much fuel had been saved, because it was a device designed to save fuel on semi-trucks. And it really drove sales in a way that wasn't possible even just a handful of years earlier. So yeah, so I got this really cool trajectory of going from like a mechanical engineer all the way to now interfacing with kind of cloud services through cellular devices in the IoT space. Everything I learned always came back to help me in different parts. So it's been really cool. But yeah, so given that like my career experience so far, I've only been an engineer for 10 years, so I still have a long way to go, hopefully, of learning and continuing to develop my career. But 10 years is a pretty cool milestone. So I think it's really neat to kind of look back and kind of see what's changed in that time period. So when I think about engineering, I think about things, this is just the top and bottom doesn't really matter. These are just in scales of differences. So I like to think of like mechanical things as like on the bottom, and then electrical engineering, and then you have kind of firmware development, then cloud, going up towards the top in terms of different levels of abstraction from needing to physically make something. If you're a mechanical engineer, you have to deal with things like molds and presses. When you're an electrical engineer, a lot of that manufacturing has been not outsourced, but there exist standard procedures for how to make a printed circuit board that everyone can use. That doesn't really exist in mechanical engineering. You kind of have to make your own custom stuff. And so as you get higher, you enter things like firmware development there's whole software packages that are able to be scaled really easily. And then of course, at the cloud level, it's very easy to scale. This is my personal way of looking at something. But going with that, I want to kind of describe how stuff's changed in the 10 years since I've been an engineer to kind of work towards this thesis of what's changed and why and what we can do about it. So in 2010, this is my mechanical engineering example. In 2010, 3D printers were super rare. And I remember that you used to have sign-in sheets. To use the 3D printer, it was a big deal. People were super concerned about wasting material. And now, 10 years later, it's like 3D printers are all over the place. You can buy them at Staples. So it was really been really interesting to see how much this has changed. There's a lot of reasons for this. We're not going to go into those right now, but just the observation that the way that people design things mechanically now, they can utilize 3D printing to dramatically reduce time to build things. So if your training was built around the idea that 3D printing was hard to do, and all of a sudden it's not anymore, it's going to be really interesting when you're trying to solve problems. You're not going to realize the opportunities will have moved faster than you're aware of. So someone graduating from college now is very aware that 3D printing is quick and easy and fast. And if you want to just have something to test you can put in your hand, you'll print it. Another thing that happens is electrical engineering. There's tons of access to services and companies, not exactly that in the last 10 years have really risen to the top in terms of providing boards that are just ready to buy. They have solved a lot of the problems and they're relatively affordable. I've got a photo right here of at the very bottom. It's a Wi-Fi connected chip. This chip was developed abroad to be low cost, and then hobby makers have been tweaking on it, translating manuals to enable it to be pretty accessible. So for $10, again, it really depends on your range of cost, but it allows that there's this range that this used not to be accessible. Another example, actually, I'm gonna hold on here for a second with regards to electrical engineering. Sorry, I'm simultaneously timing myself and making sure I'm not going too fast. So with electrical engineering, what's really neat that I did want to focus on this part is that specifically what started to happen is that I use a lot of tools from a company called Particle, and they actually develop a chip that has built-in functions to connect to the internet, which used to be really hard when you were using an Arduino connected with maybe a phone module. It wasn't impossible, but it was just really tricky. There were a lot of manuals to read and it was very hard to do. All of a sudden, there's a company that exists that started selling its products in 2016, I think. Yeah, 2016, called the Particle Electron, that enabled 3G service with a built-in library and functionality. And this is a total game changer because now all of a sudden you can access the internet without having to know how to do it. It just works, and it lowers the bar for people to get access to it. And that's kind of the theme of where this is going for the improvement, is stuff is now easier to do. And so you have to be more creative in how you bring these services together. One thing that's next, going through our step, this is 3 of 4, is firmware development. Not a ton of stuff to write in photos because it's hard to just take photos of code. But what's been really fascinating is how the open source community has actually, for instance, Adafruit, if you buy a board, let's say that I want to make a speaker work, and I have my I have a microcontroller. There's a breakout board that they've written software for to run on your microcontroller that will power their board. Now, it's not free. It's not easy for them to make this, but they make it because you now are open to buying that board because now you can use it easily. If they didn't provide the firmware, it would actually make it more difficult for them to sell the product. So actually the idea of industries being built around free service, you provide something that enables the access, has actually been a really cool model. There are companies like Red Hat that actually develop Linux architectures that Linux is free to use. It's open source, but they actually sell services that use it. There's examples of this with computational fluid design as well, where there's open source community developed products that are then create the industry that's behind them. Okay, so then coming to the last one, this is the part where stuff really gets exciting, is that there are a ton of new services that exist for cloud storage and compute. This is this is where it's neat that I was a mechanical engineer kind of starting my career and have kind of backed into learning more about the software space, because it definitely gives you some perspective, whereas if you were just exclusively working in software the whole time. What's really incredible is actually what services like, maybe you might have heard of Amazon Web Services, GCP, I think it's Google Cloud Platform, or another one is Microsoft Azure. What they are is they're actually servers that are, instead of being a single computer that you used to need to run a website, they've developed a framework that allows multiple computers in multiple different areas the ability to run the same code within one machine so they can sell services to other people. Now that sounds pretty complicated, but the point is that it enables reliable service without the individual needing to provide the hardware. They've abstracted the hardware. And so this is the same kind of theme through all these examples, is you're basically abstracting the hardware. So for instance, in the mechanical engineering example, you used to have to, if you wanted to test how something worked for how a grip or something would feel, you would need to make a mold. Now you can abstract that using 3D printing. The 3D printer, you can make shapes that are impossible to make in tooling. In fact, there is some there's a company that makes rockets in New Zealand called Rocket Lab that is 3D printing the hardware for its rocket. And it's able to, because the molding for that type of material, and this is a metallic object, not plastic. And the reason they do that is because the number that they're printing, the number of rockets, is relatively small, but it's more affordable than making the custom molding, the custom tooling required to do that. With printed circuit boards, again, stuff's abstracted. This has been kind of going on earlier with printed circuit board design, but I would say the barrier to entry is lower. The software access makes it easier, and of course, printed circuit boards are a really cool thing to look at if you have a chance. Then with regards to firmware, there's open source services that are providing software for folks to be able to use. And that has really kind of exploded in the last 10 years. And then finally, with regard to cloud services, you have access to compute power that wasn't really accessible before when you had to build your own hardware. Now you can simply sign up on your, I've got my MacBook Air. I can run across millions of rows with super high powered computations from the comfort of my living room, just interfacing through my computer without needing to have a tower stack running at the right optimal temperature and thermal efficiency. So we're abstracting out stuff. And so how is this happening? Well, it's happening because this innovation is being driven by software development. So my opinion is that this innovation in the way that mechanical engineering is advancing, we're able to do computational fluid dynamics at a high level, make advanced structures. Circuit boards are getting smaller. And then I mentioned the firmware is getting more easily accessible, and then the cloud's getting is easier to use as well. This is all being driven by improvements in software development. So I think this is I'm sure there are a lot of thoughts on how to do this. My thought for how this is happening is I think it's because software development is not limited by physical space. You don't need to have tooling made. It's not limited by the laws of physics. Your turnaround time is much faster, and anyone in the world can access it, which really opens up so many more people to work on your problems. So what's a great example of how we can keep pace with this incredible software development? Well, I will provide you with a case study. So some of you may be familiar with, there was a big push maybe 1 or 2 years ago, I'm gonna say 2 years ago, for this micro mobility with scooters. All of a sudden, across the country, everyone had these dockless scooters that you could access with your phone. You simply could connect your credit card to an app on your phone that would enable you to rent a scooter by scanning a QR code. Was there if we were look back at the time period, was there some dramatic shift in scooter technology or battery storage that enabled Bird or other similar companies to really push for to make scooters mainstream? No, actually it wasn't. It wasn't that there was electric scooters had been around for a number of years. What changed is someone had the idea to connect the scooter to the back end of a service to allow people to rent it with their phone. Because nobody really wants to, it's not as popular to own a scooter, but nobody could deny it was super fun to ride. So what's super fascinating is you have these great examples where you have imagine renting a scooter without the back-end software connectivity. I'd maybe write down on a piece of paper, I'd mail it to Bird, Bird would mail me an invoice. That's just not realistic. And so that's the key. So when we take projects, the way to keep pace with modern software innovation is to always make sure the products you're working on, if possible, can connect to some back-end service or have the forward thinking, can project out far enough to be able to capture what's coming next. It's really hard to do. It's something that I'm working on a lot in my career. But for instance, if instead of making a device that just works today and I test it once, something I think a lot about is how can I scale this? And that's the thing that I didn't used to have to answer. In 2010, no one was, the mechanical engineer, with software problems were pretty simple, make a door open, close. But now we have even garage door openers. People want to know, well, can I use it on my phone when I'm at work or in a different country? Can I check when I'm traveling? These are all at that next step is now the norm. And that's where it's really going to be where the extra challenge comes in, looking forward. So 2020, very exciting. A lot of new opportunities that exist. Again, micromobility being an example of a simple physical thing, electric scooters. And they took that and they turned it into $1 billion valuation. So that's something I would challenge you to think about. And with that, does anyone have any questions? Thanks so much.
Well, I got a question that I saw come through on the chat.
Oh, shoot.
What is the, if you were in high school, what kinds of things would you be looking at given where you are in technology and what the trends that you're seeing?
Well, I would say it's most important to do something you love to do. It's going to be really hard to do something if you don't enjoy what you do. So do what you love doing, find what you love doing. That's probably the most important thing. But it would be great. There's a lot of, one thing that's, and just check, was the question about what types of subjects to study or what sorts of clubs to join?
What advice would you give somebody, given the trends that you're seeing in technology today, what kinds of things would you suggest a high school student do to engage in that?
I think a really good opportunity is if you have the chance is to take a programming class and kind of get your feeling for your interest in it. And also, yeah, that would be what I would say is a great opportunity. By the way, to put it in perspective of when I was in high school, so I graduated in 2006. Back in my day, I'm not even that old, but back in my day, the thing to do was to be sure that you could type effectively on a keyboard. So the bar really has raised. It's gone from being able to not look at your fingers when you type to now understanding object-oriented programming. So I definitely don't envy new students, but the bars, I would say a general getting familiar with software is a really good opportunity.
Okay. Yeah. Great. I don't think we have, unless Eden, you've got other questions.
No, thank you.
Oh man, you got it. No problem.
Thanks so much for all your talk, Adam. We really appreciate it.
Yeah, no, it's great. Yeah, that's all I have.
All right. All right. Thanks so much, and we'll look forward to seeing you next time at BlueStamp.
Perfect. Sounds good. Thanks, Dave.